Okay, Algebra 2, we are here working on a Chapter 3 test review. So hopefully your teachers have posted this PowerPoint up for you to work on your own, and then you can come to this PowerPoint and check your answers. Now, if you haven't worked any of the problems, then don't just go through this and copy everything down. Pause it, work it yourself, and then watch me work it so that you can be making sure that you're getting the right answers. All right, so we're going to start. Maybe we're going to start. There we go. By solving a system with graphing. So we have two equations, and we're going to solve them by using the graph that's given to you here below. So we're going to start with this first equation. We have to get it into slope-intercept form, so we're going to manipulate it, and y is going to equal negative 4x plus 8. So we're going to start at 8. We're going to go down 4 and over 1 and down 4 and over 1 and down 4 and over 1 and down 4 and over 1. And we're going to connect, make a line. And then we're going to do the next one. So the next one's going to take a little bit more manipulation. So I'm going to start negative 3y equals negative 2x plus 18. So I move that 2 over, and I'm going to divide everywhere by negative 3. So y is equal to 2/3 x minus 6. So I start at negative 6, and I go up 2 and over 3, up 2 and over 3, and I don't have to do as many because you can see where our intersection is after I did that second point. So our point of intersection is right here, which was 3, comma, negative 4. And so that is our solution. Okay, solving by graphing. All right, the next one is solving by substitution. So with substitution, we need to have one of our equations with the variable by itself. So this one is a good one to start with because the x doesn't have a coefficient. So by just moving the 3y over, I get x equals to negative 3y plus 3. So in the second equation, I'm going to replace the x with what x equals. So I have 2 parentheses, negative 3y plus 3 minus 4y equals 6. So we distribute and get negative 6y plus 6 minus 4y equals 6. Combine like terms, negative 10y plus 6 equals 6. Move the 6 over and we get negative 10y equals 0. Divide by negative 10 and y equals 0. So don't be fooled when it equals 0. That's not no solution. I still have a variable y. Okay, and then I'm going to take that 0 and I'm going to plug it into this up here so that I can solve for x. So x equals negative 3 times 0 plus 3. So x equals 3. So to check it, just to make sure that we did it right, when we get this funny 0 right here, we might want to go ahead and check it. So we already plugged it into this equation up here. So we're going to plug it into this equation over here just to make sure that it works. 2 times 3 minus 4 times 0 does equal 6. It does check. So our ordered pair is 3, 0, and that is the solution. Okay, so that's substitution. When we move on, we do it by elimination. So we're looking at these, and to eliminate a variable, I'm going to eliminate the x. So I'm going to take the top one and multiply it by 2. And I'm going to take the bottom one, and I'm going to multiply it by 7. So the first one, when I multiply 2, I get 14x minus 6y equals 12. And the next one, I get negative 14x plus 35y equals negative 70. And add those, and I end up with, I didn't bring my calculator in here, so I'm going to look at my little cheat sheet here. 29y equals negative 58. So y equals negative 2. Okay, now I can plug it back into either of the ones that we started with. So I'm going to go ahead and plug it into the top one. 7x minus 3 times negative 2 equals 6. So 7x plus 6 equals 6. So 7x equals 0. So x equals 0. Okay, so my ordered pair should be 0, negative 2, but I'm going to go ahead and take it and plug it into the red equation up here just to make sure that I did it right, because I already plugged it into this one. So now I'm going to plug it into this one. Negative 2 times 0 plus 5 times negative 2 equals negative 10. And that checks. So my ordered pair is 0, negative 2. Okay. All right, so we do have some word problems on the test. Word problems that have two variables. And so we're going to go ahead and set up a systems to solve this one. Go ahead and read it. I don't need to read it for you. But, so we have two types. We have type A and we have type B. Okay, so we know that we have 84 bottles. So A plus B is equal to 84. Okay, and then type A costs $6.50 per bottle, and B is $8.25 per bottle, and I spend $588. So that equation would be 650A plus 825B is equal to 588. All right, even though I like elimination much better than substitution, I'm going to use substitution anyway because that is going to be the easiest method here. So A is going to equal 84 minus B. So wherever the A is, right here, I'm going to plug in 84 minus B. So I have 650 times 84 minus B plus 825B equals 588. And using a calculator, I would get 546 minus 6.5B plus 8.25B is equal to 588. So 546, combining like terms, plus 1.7B is equal to 588. So 1.75B, move the 546 to the other side by subtraction, equals 42. So B is equal to 24. Okay, then just plug it in to this one up here. So A is equal to 84 minus 24. So A is equal to 60. But this is a word problem, and word problems deserve word answers. So I'm going to write really small so I can fit it in. Shipment contains 60 bottles of type A and 24 bottles of type B conditioner. Very good. All right, so the next thing that we did was graphing inequalities, which was getting us ready for linear programming. But we'll start with the simple graphing inequalities. So we have to graph the first line. You got to get it into slope-intercept form. So when we do that, we have 2y is less than negative x plus 2. So y is less than negative 1/2 x plus 1. So this is a small graph, but we can fit it. We start at positive 1, go down 1 and over 2, down 1 and over 2. And I'm going to work backwards a little bit. Whoa, sorry. Working backwards. My hand kind of covers it. Because this is not or equal to, it is a dotted line. It's not working so well. Let me see if I can get my straight edge up here. Okay. And it's less than, so it's shaded below. And then the next line is this one. So we get it into slope-intercept form. Y is less than or equal to negative 3x plus 3. So we start at 3. Whoops, that's not 3. That's 3. See if I can get that eraser to work. Sort of. Okay, you guys get it. So there's 3. Okay, and then we're going to go down 3 and over 1. Okay, and this line is going to be a solid line because it is or equal to. And it's less than, so it's shaded below. So this is my double shaded region. And that's the answer to the system of inequalities. So we are ready to move on to linear programming. All right, for linear programming, I'll give you a second. Actually, you can pause it and read the problem. We are going to take 2 slides for this, so make sure you go ahead and copy down the problem because when I switch to the next slide, it's going to be a blank slide. All right, so we have a baker baking corn muffins and bran muffins. We're going to look at the question to try to find out what our variables are going to be. So how many trays, there's a typo, sorry, of each type of muffin should the baker make to maximize his profits? So we're making corn muffins. These are trays of corn muffins. And B will be trays of bran muffins. Okay, so we have our variables. Now we need our inequalities, so or our constraints. So what is our constraints? What is keeping us from making 1,000,000 of each type? Well, what's keeping us from making that is that I only have 16 cups of milk and I only have 15 cups of flour. So that is what is making us our restraints. So we have a constraint on milk and we have a constraint on flour. Okay, so let's look at the milk one. The corn muffins take 4 cups of milk. So 4 for every tray of corn muffins, plus the bran muffins take 2 cups of milk. So we need 2 cups of milk for every tray of bran muffins. And that needs to be less than or equal to 16 because that's all that we have. Okay, now let's take a look at the flour. So the corn muffins take 3 cups of flour. So for every tray of corn muffins, we need 3 cups of flour, and the bran muffins also take 3 cups of flour, so 3C. And we only have 15 cups of flour, so less than or equal to 15. Now don't forget, oops, that was supposed to be for bran. There we go. All right, so don't forget that we also need that C has to be greater than or equal to 0, and B has to be greater than or equal to 0. So we'll put corn muffins down here, and we'll put bran muffins there. So we'll get those 2 easy ones in. We know that we have to work in the first quadrant for linear programming. Okay, so I am going to graph the first line, and before I do that, let's look at these. I think I'm going to do every 2. And then the same. The better your graph is, the more likely your answer is going to be given to you by the graph instead of having to do a system. All right, so we're going to graph this first one right here. So I'm going to graph it by intercepts. So when my corn is 0, I am going to have 8, so I need some more, 6, 7, 8 bran. And when the bran is 0, then I'm going to have 4 on the corn. Okay. Then on this one, we're going to have 5 and 5. So I didn't connect those dots. So let me go back and connect those points. The red one. Then the black one. And they are both less than, so we're going to take this point right here. I'm going to shade all in here. All right, so don't forget to write this statement down. We're going to write that on the next screen because I'm going to run out of screen place. But if I can go ahead and write it here at the bottom. The profit, which is the optimum function, okay, the profit function is $3 for every corn tray and $2 for every bran tray. So write that down because that's going to be important once we find these corner points. Now you can see that this corner point is 0, 0. And this corner point is 4, 0. And this corner point is 0, 5. And if you did this super accurately, you know that this point is 3, 2. But some of you won't have that, and it's not very accurate on my graph because of the programming system. So let me go ahead and do the systems to show you that this point really is 3, 2. Okay, so here's our blank screen, and we're going to do that system. So we had 4 4C plus 2B is equal to 16. That was one of our constraints. And 3C plus 3B is equal to 15. So if you don't know that point, you're going to do the systems to try to figure out that point. So I'm going to take this top one and I'm going to multiply it by 3. And the bottom one I'm going to multiply by -2 to drop out the b's. So I get 12C plus 6B is equal to 48. The bottom one, -6C minus 6B is equal to -30. So 6C is equal to 18. So C is equal to 3. Plug it back in, and you get 9. I'm going to just plug it back into this one right here. So you get 9 plus 3b equals 15. 3b is equal to 6. So b is equal to 2. So that point truly was 3, 2. Our other points were 0, 0, 4, 0, and 0, 5. Right, so then we needed to plug them in to our profit, which from the last screen, hopefully you have this written down. And we're going to plug them in. So this one's 0. That's pretty simple. This one's 12. This one is 10. And this one actually takes a little bit of work. Not much though. 9 plus 4, which gives us 13. So our maximum profit would be $13. And how do we get it? We get it by selling 3 corn and 2 bran muffin trays. So we're going to write it to maximize profits of $13. The baker needs to make 3 trays of corn muffins and 2 trays of bran muffins. Okay, so then we get to move on to systems of 3s. So here's my system of 3. And we're going to move through this really quickly. We're going to go ahead and get rid of our y's first because that looks easiest to me. So I'm going to just take these two straight over here. Negative 3x plus y minus z equals negative 2. And 2x minus y minus 2z is equal to negative 12. My y's drop out, so I get negative x minus 3z is equal to negative 14. And then I am going to do the next two right here, but I got to multiply this one by a 2. So I get 4x minus 2y minus 4z is equal to negative 24. And I'm just going to rewrite this one. And I get 4x plus 2y plus z equals 1. My y's drop out, and I get 8x plus a negative 3z equals negative 23. So the z's look pretty easy to drop out. Now I just have to take this one and multiply it by negative 1 because that was a negative 3 and this is a negative 3, so I need to make it a positive. So we get negative 8x plus 3z equals positive 23, which gets me negative 9. X equals 9. So x equals negative 1. 1 down, 2 more to go. I'm going to take that one and I'm going to plug it right back into this one. So I get negative 8 plus a negative 3z equals negative 23. So negative 3z is equal to negative 15. So z is equal to 5. 2 down. And then I'm going to use this bottom one right here and plug those in. So I get negative 4 plus 2y plus 5 equals 1. So 2y plus 1 equals 1. So 2y equals 0. Don't freak out because remember 0 is a number. So y equals 0. And my ordered pair is negative 1, 0, 5. Sorry, that's an ordered triple. Okay. And to check them, plug them back in. but we're going to run out of time here, so I'm going to just move on to the next problem, which is a 3-variable, 3 equation problem with words. All right, so read it. And then while you read it, make sure you pause it because I'm going to move on. So we're going to start with 3 slices of pizza plus 4 breadsticks plus 2 sodas. And I don't like S's, so I'm going to use D for drinks. Costs $13.35. And the second one is 5 pizzas plus 2 breadsticks plus 3 sodas, which is going to be a drink, equals $19.50. And the next sentence is a little strange. It says 4 breadsticks and a soda, which is a drink, equals 30 cents more than a slice of pizza. So that's going to have to be the pizza plus 30 cents. Now that one looks weird and it's not in the right order for us to do what we want to do with it. So let's move the P out to the other side and get negative P, so we're not going to use this anymore, plus 4B plus D equals 0.30. And now we have them all lined up right. We just manipulated that one. So this one is going to take us 2 screens also, so make sure that you are following along carefully because we're going to have to move to the other screen because I write too big. So we're going to get rid of the B's. So I'm going to take this one and I'm going to multiply it by -2, and we're going to move them over here. So we get 3P plus 4B plus 2D equals $13.35. And this one, when I multiply, I get -10P minus 4B minus 6D equals $39. Crosses off, and I get -7P minus 4D equals -25.65. And then I'm going to use this next equation right here, and I'm going to get rid of the B's, so I'm going to do the same thing that I did here. I'm going to multiply this by -2 and move it down. So I get -10P minus 4B minus 6D equals 39. And that drops out, and I get -11P minus 5D equals, oops, this is supposed to be a negative, sorry, from the negative up here that is not very shown very well. So I get -38.70. So I need to combine these two, but I can't do that without multiplying both of them. So I'm going to multiply this one by a 5, and I'm going to multiply this one by a -4 to get them to drop. So I'm going to move down a little bit, and this one is going to be -35P minus 20D equals -128.25, and this one's going to be 44P plus 20D equals 154.80. The D's drop out, and I get 9P equals 26.55. So P is equal to 2.95. A pizza is 2.95. Then I have to plug it back in. So I'm going to plug it in right here. Get -11 times 2.95 minus 5D equals -38.70. If I'm going too fast, then make sure that you're pausing while you're writing, because I am writing really fast. So I'm hoping that you've already gone through this and are just checking your work. Okay, but if I'm going too fast, just pause it while you catch up. So I have -5D equals -6.25. So D is equal to $1.25. So the drinks are $1.25. All right, and then finally, we're going to plug both of them in to this equation right here that I crossed out. Okay, so we're going to do 4b plus 125 equals 295 plus 30 cents. So you have 4b plus 125 equals 325. So 4b is equal to 2. So the breadsticks are 50 cents. Now I've put another slide in here to write my answer, but because we are so close on time, I don't want to take too much of your time. You guys know that this is a word problem, so it deserves a word answer. So please write a word answer. And we're going to skip the blank screen, and we are going to go to matrices. So this matrices has scalar multiplication as well as addition. We're going to go ahead and do the scalar multiplication first. So I get 1, -1, -2, and 4. And I'm going to add 4, 6, -1, -2. And that gives me a total answer of 5, 4, -2, and 2. Okay, after all of those linear programming and systems of 3, that one seems rather easy. Let's go to the product though. Product is not as easy, but we need to first check to see if this is if we actually can multiply it. So rows by columns, so this is a 3 by 2, and this one is a 2 by 2. These two are the same, so it does work, and our answer needs to be a 3 by 2. Okay, so when I do this, I actually show my work. So I'm going to make a great big matrix, and then over here I'm going to make it smaller where I simplify it. Okay, so your first row by column, you end up with -2 minus 6, which gets me a -8. And the next row, same row, by next column, you get 2 plus 10, which is 12. We move to the next row, and we go back to the first column, and we end up with -6 minus 3, which is -9. And we go back to that second row, but now do second column, and we get 6 plus 5, which is 11. And finally, we're on the third row, and we do the first column, and we get 8 plus 18, which is 26. And we do the third row and the second column, and we get -8 minus 30, which is -38. And that is our final product. All right, so this is it, and I'm going to try to finish before 35 minutes. So I'm going to talk really fast. Make sure that you study. If you have any questions, come in and see your teacher, and good luck on your test. Make a smiley face. Okay, good luck.